Starting from lesson 90, we will be beginning chapter 11 in your textbook with the studies of probabilities. We begin by looking at set theories and Venn diagrams to learn some vocabulary that you will encounter in the studies of probabilities. First, we have the universal set, U or S. In the Venn diagram, that's basically anything that's contained in a box, in a rectangle. I can label that U or S. And this is the largest possible set of all the elements under consideration. Okay. Next, an empty set means there is nothing found in this particular set here. It is sometimes known as null set as well. Next up, we have complementary sets. So complements are marked using an uppercase letter. In this case, let's call it A. So anything that satisfy the criteria described by set A can be placed in the circle. Anything that do not satisfy the criteria of set A, we call it A prime, which is the complement of A. So if a universe only contains event A, then A plus A prime must equal to the total number of elements found in the universe set. Then we have disjoint set. So let's say we have set A and set B here. As you can tell from the Venn diagram here, they do not overlap. There is nothing in common. So the intersection, which is symbolized by the upside down U, this is the intersection of two sets, or you can see it in the next description. And we use the word N to describe that. Okay, it's null. We use N of A and B as the symbol or the notation to describe how many elements are found in A and B, or in the intersection of A and B. So for disjoint sets, of course, there's nothing. Okay, sometimes this is known as the cardinality of a set. Okay. Next up, intersections of sets. So once again, the notation is upside down U. We usually read it as A and B. So if this circle is A, this circle is B, I have the universe out here, we are talking about the overlapping region. On the other hand, you can have the union of sets A or B. So the keyword here is or. The union symbol is a U, and if this is A, this is B, found in the universe, then A or B is anything that is either inside A only, anything that is inside B only, or anything found in both of them. Okay, so this is a more, in a way, forgiving notation or term or operation versus and. Okay. Now let's talk about axiomatic probability systems. Here are some key terms. So an experiment is defined as a sequence of trials in which a physical occurrence is observed. So it's kind of like doing a lab. You're going to have multiple trials, right? An outcome is a possible result of the experiment. The sample space is a set of all possible outcomes, and a simple event is an event with exactly one outcome. And when we talk about theoretical probability, you are comparing how many times a certain event occurs over the number of outcomes found in the sample space. And as you know, the number of outcomes in event A n of A cannot be greater than the number of outcomes in the sample space n of U. That means the highest value of probability P of A would be 1, and the lowest probability is 0. It never occurs. Event A never occurs. Okay? Let's take a look at the first experiment. We're tossing 3 coins. We want to represent this using a tree diagram. Okay? So the way we can think about this is that, well, what happens when I toss the first coin, then the second coin, and then the third coin. All right. So let's start. When I toss a coin, what are the possible outcomes? Heads and tails. And then now let's toss the second coin. If I got head in my first coin, I can still get heads and tails in my second coin because they don't interfere with each other. Same thing with getting a tail in the first, I can still get either a head or a tail in the second coin. Now toss coin 3. I would expect the same thing. When we say the outcome of tossing 3 coins, it is really a summary of what happened in each branch in the tree diagram. So what are the possible outcomes? I can get head, 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 heads, heads, tails, heads, tails, head, head, tail, 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 head, head, tail, head, tail, TTH, and TTT. So how many outcomes are there? 8 in total, right? So now let's see. If A is the event of getting 3 heads showing, find is probability. So let's call P of A. Well, how many outcomes out of the 8 involves 3 heads? Only 1 out of 8. And what about the probability of 3 heads not showing? Well, this can be deemed as the complement of event A. I can either count out of the 8 trials how many of them do not have 3 heads, or knowing that these are complements, I can also subtract P of A from the maximum probability, which is 1, right, of the universe, and get 7 out of 8. Same thing. So let's name this relationship between the events in B1 and B2, and I kind of gave it away. These are called complementary events. And we said that when I add P of A and P of A prime together, I get 1. Okay. So how about the probability of getting exactly 2 heads? So P of 2 heads. You can locate them from the outcome list. So 2 heads is this one here, this one here. I think that's it. So that's 3 out of 8. Okay. The next part of this video asks you to carry out investigation 1 found on page 684 in your textbook. Take some time, pause the video, and process and work out this investigation. And then I'm going to take up the answers using part 2 of this lesson video. After we take up the investigation, we will also work on some more examples related to the investigation. Good luck!